Okay? So this is a key system element. And also, in addition to that, if we use an information collecting mission, so small ground sensor are also included as system element. So as I said before, 1,000 such kind of ground sensors will be also the system element. And so you should add some cost for such kind of ground sensors. And this shows the trade-off between the increased number of satellite and ground station and the cost. Okay, so the number of satellite and ground stations are important design criteria. The merit of more satellites against the increased cost of trade-off should be trade-off. So with more satellite, of course, you can obtain more coverage of the Earth per day for remote sensing mission, and more frequent observation of the same area for remote sensing mission. And more data can be retrieved from ground sensors for information collecting mission, and more space available for rental space mission. And with more ground stations, you can obtain more time to receive satellite data, resulting in more images data. Image data can be downloaded per day, and so on. And less latency to download urgent data. So these are the merits of the say additional increased number of satellite, and of course, increased number of satellite and ground station requires additional cost. So please trade off between these two factors. And the orbital design is very, very complicated. So we have very simple assumption that the orbit is assumed to be sun-synchronous orbit. So it goes around north and south and over the Arctic and Antarctic oceans. Okay, and so first you should define the revisit interval for each satellite. For example, if you put 10 days as a revisit interval, and then the first day it goes over this, and then it moves, and the second day it goes over this. And so a certain area around this area can be photographed, okay, by this satellite for the remote sensing mission. Right. And the coverage area is assumed to be calculated as 5 times L. L means the revisit interval. So if you have a large revisit interval, for example, maybe 20 days, okay? So the interval between the geographical interval between the orbit is very small, like this, and then you can cover almost all the area, for example, 100%. Okay? And if you have a 40 days interval, of course, it is 5 times 40 is 200. So more than 100 is assumed to be 100. So in this case, also you can obtain almost 100% of the Earth coverage. Okay. But the revisit interval very large, 40 days, right? Yes. So this is a trade-off between the revisit interval and the coverage area. So if we have more than one satellite, so this is also a very simple assumption. For example, this is one satellite case. So if we have only one satellite, day 1 it comes over here, and day 2 it comes over here. And after 10 days revisit interval, on the 11th day, it goes over the same passage as the day 1, right? Yes? And day 2 is the same as day 12 is the same as day 12, right? Yes. And so the revisit interval 10 days, and as I showed in the previous slide, the coverage area is 5 times 10 is 50%. And if we have one more satellite, if it is coordinated very well, if the two satellites orbits is coordinated very well, then it looks like this. The first satellite number 1 is here, and then the next day is going here. And the satellite number 2 is first day right here, and the second day right here. So as a result, the revisit interval can be reduced to 5 days, and conserving the coverage area is 50%. Okay, so if you have more satellite, you can while conserving the same coverage area, and you can reduce the revisit interval. So this is a very simple assumption. And the dependency of the launch configuration. So as I said before, the coordinated orbit and the non-coordinated orbit. So coordinated orbit case, you can effectively or efficiently reduce the revisit interval, but it requires additional cost because these satellites will be launched as a piggyback, and so you cannot select the final target orbit. So we assume that if we use a coordinated orbit, you should add more money for the satellite launch. Okay, so this is a coordinated orbit case, and this is non-coordinated orbit case. In each case, we are very let's say simple assumption of the cost. And also, you have another option to buy Hosa rocket to launch many satellites all together. So this is the case here. So also, we have a very simple cost assumption in this case. And we have also project cost breakdown, including the first burst cost and the payload cost, remote sensing, infrared, and communication payload, and the rental space. So for each cost items, we have a very simple assumption, cost model, depending on the performance of each equipment. And so these are included in the Excel file, which is also one of the textbooks, so please refer to that. And also, we have a ground station cost model and launch cost model. And also, for the data collecting mission, information collecting mission, we have a ground sensor cost model. Okay, so maybe that's all. Okay, so if you have any questions, I'd be happy to answer.
Yeah, we'll have the discussion time, so you can ask questions. So maybe we can base
Kawahara-san.
Yes, talking about evaluation criteria for academic field.
ありがとうございます。